I had a request from some of you to go through a stoichiometry problem, to take our time and slow the process down a little bit. I know that starter, we went pretty quick through that, and if you were struggling, that probably didn't help you a lot. So what I want to do at this point is go through a stoichiometry problem with you and just take our time with it. All right, so hopefully you've got a piece of paper and you're all warmed up, tuned in at this point. I'm going to switch over to my iPad here pretty quick. What we're going to start with is a simple reaction of Ca, calcium, reacting with oxygen. These are the first 5 steps. We're going to write the reactant, write the product, check for diatomic elements, balance the product, and balance the reaction. These are the 5 steps we've been working on for a while now. So I'm going to zip over here to, there we go. All right, so calcium and oxygen. I'm going to start out with the symbols, Ca and O. Notice I am writing large. I'm leaving lots of space because I've got other numbers to write. Okay, then I'm going to write the product, Ca and O. Okay, the Ca came first because it's furthest to the left. All right, that's step 1 and step 2. Step 3, diatomics. Okay, oxygen is diatomic, so it needs a 2. This other oxygen over here is not diatomic, so no 2. All right, let's balance the molecule. Calcium's plus 2, oxygen minus 2, so we don't even need any additional numbers. It's balanced just the way it is. All right, let's go ahead and see where we're at now. We have 2 oxygens on the left, only 1 on the right, so we're going to need a 2 there. And then a 2 back over here because now we have 2 calciums and only a 1 there. All right, so that is those first 5 steps that we've been working on for quite a while now. So I want to go back just briefly and look at our steps for the rest of the stoichiometry process. And let's see, just right there. There they are. So those first 5 in red, we already did. So now the second group of them, we need to draw some lines, and then we're going to kind of move through these next 6 steps, kind of moving in a circle. All right, so let's go back over to the iPad a second, and we'll get back. All right, right there. All right, so what it said was step number 6, draw lines. What I mean by draw lines is I want a line above each one of those numbers, just 1. Then I want 2 lines underneath. The one on top, always label as moles. The one on the bottom, label as grams. Okay, all we're doing, that's sort of an art project there because all we're doing is drawing lines and labeling things. All right, the next step is for us to write what we are given. And so in this process, what I'm going to do is I'm just going to write some numbers here and say that we are given 80 of that and 32 of that. And I just, that's what I'm giving you. I have the store of chemicals, and so that's just how much I'm telling you. All right, if you go over to your periodic table, you will see that calcium has an atomic weight of 40, and O2, okay, oxygen has an atomic weight of 16, but there's 2 of them, so that means it has an atomic weight of 32. All right, our next step is convert mass to moles. Calculate the moles. So pretend that there's a little division right here. Okay, 80 divided by 40, we're going to write that answer right there, and it's 2. 32 divided by 32, and we're going to write that answer right there. That's 1. All right. Our next step is to identify the limiting reactant. The limiting one is the one we run out of first, and when we run out of either calcium or oxygen, then the reaction stops. So what I'm going to do is I'm going to circle these top 2 numbers. Okay? Notice I'm not down in the masses at all. Okay? I'm up on the very top. And I just do division. So 2 divided by 2 is 1, and 1 divided by 1 is 1. In this case, they're both the same number. And so I run out of both reactants at the same time. They are both equally limiting. So I'm just going to pick one of them. It doesn't really matter. I'll pick that one. All right. The next step is I need to know how many moles of product I'm going to have. The way that I do this is I set up 2 ratios. The 1/1 came from right there, and x/2, and that comes from right there, because that's x right there, x/2. All right, now I just need to do cross multiplication, and x is going to equal 2. My last step, I just need to convert moles back to mass. To do that, I need to know the atomic weight of calcium oxide. So this CaO, all right, so Ca is 40, O is 16. When I add those together, I get an atomic weight of 56. Notice I did not come over and add 40 plus 32. Okay, we don't want to add across that way. Add them up separate. So 56 is what one of them weighs. But I have 2 of them. It says so right there. I've got 2 of them. So 2 times 56 is 112 grams. Okay? And that's my final answer. So hopefully that helps you a little bit and moves you forward in the stoichiometry process.